Hi everyone, we are finishing our unit on similar triangles with some notes on proportions within triangles with parallel lines, and then a little bit more about parallel lines with a transversal. So first, a theorem. What we say is that if we have a line that is parallel to one side of a triangle and that line intersects the other two sides of my triangle, then it'll divide the two sides proportionally. Which makes sense because you'll think about the fact that if we have a line here, so let's say we have triangle ABC, and we draw a line that is parallel to BC, but it doesn't matter what side you make it parallel to. Now let's call this EF. And what I know is that because these two lines are parallel, the distance between these two lines will remain constant, right? So I know that my distance from point A to E and A to F, and then A to B, A to C, E to B, F to C, those will all remain in proportion. Okay. So my ratio here, there's a few different ways we can think about this, but we can think about this as I know that A to E is to EB as AF is to FC. Right, so I know that here, 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 those will remain in proportion. You could also think about this as like A to E is to A to F, as EB is to FC. There's literally tons of different ways you can think about this, but let's use our new theorem in an example. So in our figure here, we know that QP should be parallel to TS. So PQ and TS are parallel. I know that QT is 4. I know that TR is 2. PS is 6. I want to find the length of SR, which is X. So I know that I could say 6 is to X as 4 is to 2. Right? I know my sides will be in proportion. So solving this out, 4x is 12, so x must be 3. And that's the length of SR. Alright, next they want me to find the value of x. And so I see that YZ and CB are parallel. So what I know is that 12 is to x plus 1 as 9 is to x. So solving this out, 12x equals 9x plus 9. 3x equals 9, so x must be 3 again. Alright, let's walk through a proof of my theorem. So if you could, I want you to pause the video and see if you can fill in the blanks here. I think this one's not too bad. There's a certain way that I want you to write some of these justifications. So go ahead and pause, see if you can fill in the blanks, and then see if it matches with what I got. Okay, so we have QXT here. I think this should be a Y. So we have QXY, and we know that RS and XY are parallel. Okay, so I want to prove that XR and RQ are proportional to YS and SQ. Alright, so something I know is that because of corresponding angles, 1 and 3 are going to be congruent, 2 and 4 are also going to be congruent. Alright, so first thing is my given. Then again, I know that this is true because of corresponding angles. Alright, so then I can state that QXY and QRS are similar triangles, and this is because I have two angles in common, so this is going to be the AA theorem. Okay, so using my similarity, I know that XQ is to RQ as YQ is to SQ. That's literally a definition. That's a definition of similar triangles. So then I go to step 5, stating XQ is equal to XR plus RQ. So xq is equal to xr plus rq. So we're just forming our segments here. So this is just segment addition. Okay, then from here, I'm just making a substitution. So we're substituting within my proportion. Okay, I'm making another substitution here. I guess you could say it's dividing, kind of up to you. I'll say division. Okay, and then we're just subtracting. So if we get rid of the ones, that's all justification that I think we need. Alright, so that's our proof. Let's move on to parallel lines. Okay, so if we have parallel lines with a transversal, some very similar things happen. So if we have two parallel lines intersecting two transversals, then the segments intercepted on the transversals are also proportional. Okay, so what we mean by that is here you can see two transversals and I have actually three parallel lines here. Then what I know is that, for instance, AB is to BC as FE is to ED. Okay. So very similar to our triangle, except we don't have a vertex here, right? But it's essentially the same thing. Now, if we have three or more parallel lines cutting off congruent segments, then all of the segments will be congruent, right? So if I know that, for instance, here my transversal, I would say line ABC. If AB is congruent to BC, that means that any other transversal will also be cut into congruent segments. And again, that makes sense because if my distance here is the same as this distance here, this distance will never change, right? So I'm talking about the distance between my parallel lines. This distance will never change, so if the distance is the same, then obviously we'll just keep cutting into congruent segments like a slicer. Alright, so a few examples with the parallel lines. So first, given that Li is parallel to Mj, which is parallel to Nk, they want us to find Lm. Right. So this is what I'm searching for. So I know that 1 is to x as 9 is to 5. So that means 9x is 5, so x is 5/9. So that would mean Lm is 5/9. Perfect. Alright, very similar idea here with angle bisectors. Okay, and this is the last thing that we'll talk about. So if we have a ray and this bisects an angle, meaning splits the angle in half, it bisects the angle of a triangle, then it will divide the opposite side into two segments that are proportional to the other two sides. Okay, so what that means is here I know that ABD and CBD are congruent, and what that means is that BA is to AD as BC is to CD. Okay. So I am in proportion here. So BA is to AD as BC is to CD. That's what that means. Alright, last two examples. So first they want me to find XY. XY right here. So I'll just call that X. Switch. I'll call that X. So we just fill in the ratio. So I know that X is to 4 as 1 is to 7. That means X must be 4/7. Alright, so super simple. Alright, this time they want us to solve for X. So again, I see that I am bisected here. So that means that 32, I'll write up here. That means that 32 is 2x minus 2. Okay, things are happening. X minus 2 as 40 is 2x plus 5. Alright, so we do a little bit of math here. I'll get 32x plus 160 is equal to 40x minus 80. And that means that 8x must be equal to 240. So x is 30. Alright, that is it for these notes. Your worksheet is in Classroom, so let me know if you have any questions. Otherwise, have a fantastic rest of your day.